Hello everyone, welcome to episode 1 of Astronomy in the Park. I'm going to be your host. My name's Lynx. Right now it is 111 degrees, and today we're going to be discussing the Lord of the Rings, or Super Saturn, depending on who you ask. This planet is actually called J1407B, so for a few of our leading questions for this episode. Number 1, why is J1407B considered the Lord of the Rings? That's its common nickname, for those of you who don't know. Number 2, how can rings of this scale even be possible? I'm going to give you guys some comparisons to give you an idea of just how massive these rings are. It's actually pretty substantial. The largest rings on any planet that we know of, actually. And question number 3, just how similar is J1407b to our native Saturn that is in our own solar system? J1407b, just how big is the planet itself? So, for a size comparison, you can take 13 to 26 Jupiter masses approximately, and that's how big the planet itself, minus the rings, is going to be. J1407b is approximately 433.8 light years from Earth and is located in the constellation of Centaurus. There are 30 rings on J1407b compared to Saturn's 8, and they're estimated to be tens of millions of miles wide. It takes this planet 3.5 to 13.8 years to orbit its star. The planet is 16 million years old and orbits the star J1407. Its surface temperature is estimated to be 5,757 degrees Kelvin. How to get Celsius from Kelvin? Subtract 273.15 from the Kelvin degrees and you get your Celsius. I'll let you guys do the math on that one. How do we know about this massive planet? Back in 2012, scientists at the University of Rochester noticed a large eclipse for a significant amount of time around the star J1407. Eventually, they concluded that the cause of this eclipse was because of the planet orbiting J1407, which was Super Saturn. How are rings orbiting a planet even possible? There's two main ways that this actually happens. Number 1 is the bottom-up approach. A full moon moves into a planet's gravitational field and is torn apart by how strong the planet's gravitational field is. This is the case of Saturn. What do we know about Saturn? It's a gas giant, and its rings are made up of pieces of comets, asteroids, and shattered moons that broke up when they reached the planet's gravitational field. There's a bunch of solid materials such as ice and rock and other materials located in Saturn's rings. Saturn's rings are 175,000 miles wide, and there's 8 rings. Saturn has 145 moons, including the Phoebe moon, which has its own set of rings that orbit that moon. What we've learned from Saturn. Rings can have different orbits. I said that there were 2 ways that rings could form orbiting around a planet. The first one is the bottom up, the second one is the top down, which means that materials left over from the creation of a solar system begin orbiting a planet as its gravitational field grows. This means that the protoplanetary disk, which is gas formations around a newly formed planet, turn into circumplanetary disks, which is solid matter that orbits a planet in close proximity. How is it possible that J1407b's rings can be such a massive size, rings that extend past its Roche limit? What is a Roche limit? The Roche limit is the distance from the planet where tidal forces are too strong for a moon to survive. This means that once moons step outside this very strict boundary, they get ripped apart and start orbiting the planet as rings. It's been suggested that J1407b has a very strong magnetic field, meaning that matter that far away can still be stuck inside its orbit. J1407b is actually very young, and it's been suggested that a lot of its ring system will coalesce into smaller moons as time progresses. This is the case with Saturn. There's actually a few gaps inside of the ring system of J1407b, which scientists have suggested may be already formed moons. It's been suggested that if this exomoon is actually confirmed, that it could be the largest that we know of, potentially between the size of the Earth and Mars. What is the Roche limit? Inside of the Roche limit, orbiting material creates rings. They break apart and they can't hold together. Outside the limit, they coalesce into satellites, or what we know them as moons. How do you get the Roche limit? It depends on the radius of the planet that the moons are orbiting. Over the next several million years, it is expected that the rings will completely coalesce into new satellites around J1407B. It will no longer be what we know it as today, Super Saturn. What do we know about the orbit of J1407B around its star? First of all, we know that it has a retrograde orbit. This was because of a computer simulation performed by Reider. You could see that the only way that the rings stay intact as J1407B orbits its star is with a retrograde orbit. What we could actually see with the computer simulation, though, was as the planet drew closer to the star, the rings started to spread out more as the gravitational fields started to get closer together. As soon as distance grew, the rings went back to where they were before. As explained by astronomer Eric Mamajek, it was expected that Jupiter and Saturn would have had at an early stage disks around them that then led to the formation of satellites. We can currently see this happening with J1407B. He then goes on and says that until 2012, no one had seen such a ring system. This is the first snapshot of satellite formation on million-kilometer scales around a substellar object. This means that we're gathering more information on a massive scale compared to what we had before. We're actively seeing how the history of our own solar system could have played out in the past, and also watching new history take place. It's important to note that Super Saturn's rings are the first of its kind that we're aware of. So with all this research, we have a few lasting questions. The first being that since Saturn's rings are actively disappearing, and we have proof of that, just how long will J1407B's rings last, and how long will it be considered the Lord of the Rings before we find something even on a larger scale as scientists are expecting? Question number 2. How many moons will form from the rings? There's a lot of matter to work with here, so we're expecting that there's going to be a lot more in the future. Question number 3. How many of Saturn's moons were formed from its rings? Saturn currently has the most amount of moons in our solar system, so were they formed from its rings, or did they just happen to roll into its orbit? Tune in for our next episode of Astronomy in the Park. Thanks for hanging out.